This video is going to be about the things you need to know in order to be a DevOps engineer on AWS. This is going to be an outline style video where I outline a learning path of some of the essential concepts and core services that you should be aware of if you're going to be successful as a DevOps engineer using AWS. So some of the first things that I want to talk about before we even get into the world of DevOps is just some AWS essentials, because there's some key concepts, key things that you need to know about in order to even get started with DevOps as a role. So the first thing is just some general background knowledge on AWS. Things like regions and availability zones. These are kind of the building blocks of AWS. Regions are physical locations in the world where AWS clusters data centers. And availability zones are discrete data centers within those regions that have their own power supplies, networking, and internet access, and of course, access to the region that it's contained within. So these two things allow AWS to achieve redundancy because you can host your applications across many different regions, across many different availability zones. So if one ever goes down, you'll have access, or your software will have access to another one. So that's one of the key concepts to be aware of. So now I want to talk about some of the other bread and butter services that you should know about when working with AWS. The first one is Virtual Private Cloud, or VPC for short. A VPC allows you as a user to carve out a specific section of the AWS cloud that only your infrastructure will have access to. So for example, you can create EC2 machines within a VPC, and at the networking level, no other customer or piece of infrastructure will be able to access those machines. Same thing goes for databases, same thing goes for other infrastructure components as well. So the VPC is a great tool for isolation. It's also great from a security perspective, which we're going to get into a little bit later on. Now, the next one is Elastic Compute Cloud, or EC2 for short. EC2 was AWS's first service, and it really offers some bare bones functionality that a lot of other managed services depend on. So EC2s are just virtual machines that you can rent from AWS. You can rent different types of machines. They can be compute optimized, machine learning optimized, memory optimized, network optimized. There's a large variety of different types and different sizes, but essentially you can pay by the hour and rent a machine for a particular period of time and then give it back when you're done. You can do whatever you want on these machines. You can host software applications, you can host databases, you can host other things as well, but really they're there to use as you wish. So you're going to be running into EC2s a lot, so it's important to understand what they do and how they work. The next one that you're going to be seeing a lot of is Simple Storage Service, or S3. S3 is used in a whole bunch of other AWS services as a point of connection to store raw data. And that's really what S3 is all about. It's a general object storage service. It's not a database, but it's just a place to dump small files, large files, could be images, text files, JSON, whatever types of files that you want, you can store in S3. Also offers some really high scale and high availability and throughput. So if you need to integrate an application to access these files that are hosted in S3, it's certainly possible to do so. The next one is Identity and Access Management, or IAM for short. Now, IAM is the service that defines policies that specify whether or not a particular user or a particular piece of infrastructure has access to another AWS service or another AWS resource within an AWS service. So for example, if I rent an EC2 machine from AWS and I create a software application on that EC2 machine that wants to call S3, I need to create what's called an IAM policy that has access to S3 and then attach that to my EC2 instance. IAM is how we define who has access to what, and it's something you're going to be running into a lot if you're a regular user of AWS, especially if you're in the DevOps domain. Now, I really suggest you spend the time to learn IAM well, because there's some very frustrating error codes that you may run into and not be able to understand unless you're familiar with IAM concepts. I have a great video on this that I'll leave in the description section below. All right, so that's it for just some core essentials that you should know about before you get on to learning AWS. Now I want to talk about one of the key areas where you'll be spending a lot of your time as a DevOps engineer, and that is in CI or CD. CI stands for continuous integration, and CD stands for continuous deployment. Now, your role as a DevOps engineer will be to enable the seamless development and deployment, or the rapid development and rapid deployment of applications. So in order to facilitate that, AWS offers a suite of services that make this process possible. The first one is a service called Code Commit. Code Commit, for those of you that are familiar with Git, is just a source control repository that's hosted within AWS where you can host your Git repositories. You can create different software packages in any number of Git repositories and also lock down access to those repositories so only a select group can access them. Now, when you store your source code in Code Commit, often whenever you deploy a new change or a developer deploys a new change, you want to rebuild that software application and rebuild all the artifacts that are associated with that new version of code. In order to do that, we leverage a service called Code Build. And Code Build does just that. It can connect to Code Commit or any other external source control repository, and it will build your source code. It'll also run different unit tests or any other tests that you have in the directory of your source code, and it'll only be considered a successful build if it goes through all these checks and balances or passes these unit tests in this case. So we've got our source stored in Code Commit. We've built our source using Code Build. How do we actually deploy our infrastructure out there? Well, you guessed it, there's another service called Code Deploy. Code Deploy allows you to deploy your built artifacts or your built software applications to a wide variety of different AWS compute infrastructure. So you may choose to use EC2 like we just talked about before. There's some other options as well, such as Lambda functions or ECS, which we'll get to in a moment. But essentially, Code Deploy is a means for you to deploy your software applications to infrastructure. Now, you may have noticed that all of these three things are pretty interconnected. They're talking about the same type of problem. Now, there's one glue service that kind of ties all of these things together that allows you to automate the detection of changes in your source code, the automatic building of your source code, and the automatic deployment of your source code to many different environments. In a typical company, you may have a test environment followed by a production environment where traffic is actually being served by customers. Now, in order to facilitate all of this stuff, there is a service called Code Pipeline, and Code Pipeline does just that. It allows you to define a pipeline and define a sequence of steps that your source code must run through before it hits production. So for example, you can create a pipeline that first builds your source code, deploys it to your test environment, runs some integration tests, waits for a period of time as a bake period before finally deploying that source code to the production environment. So Code Pipeline glues all of these different things together to create a very effective way to deploy your software rapidly and also be confident that it's working correctly. All right, so that's it for CI and CD. I do want to talk now about infrastructure. Now, there's a couple different kind of categories of infrastructure. I want to first talk about compute. Now, as a DevOps engineer, you're going to need to be aware of the different types of compute infrastructure out there, and you're also going to need to be aware of how to create and deploy other AWS infrastructure. So this is going to be a key component of your role as a DevOps engineer. So we already talked about EC2 in the Essentials section. That's just the renting of physical or virtual servers that you can use as you wish to host your applications. What are some other options? So if you're in the world of Docker, you may already know about ECS or EKS. If you don't, ECS stands for Elastic Container Service and EKS stands for Elastic Kubernetes Service. If you're already familiar with Kubernetes, you probably already know what EKS does. It's just a managed service that hosts your Kubernetes applications. Now, ECS is kind of a homegrown, native-built AWS solution to this. So it allows you to deploy services or deploy tasks that run based on Docker containers, so you can create some full-fledged software applications using either of these two options. Now, another great option that's getting very, very popular these days is AWS Lambda. Lambda uses a slightly different approach. Instead of having to worry about the infrastructure behind the scenes to deploy our software to, instead Lambda handles all the infrastructure for you. So you as a user, you just write your code and deploy them into wrappers, which are called functions. Then AWS behind the scenes is responsible for finding the underlying infrastructure to run your code on. Also handles automatic scaling for you, so it's effective for very high throughput workloads. Also great for ad hoc jobs or maybe things you just want to run once in a while or some kind of automation task. Or maybe even like doing a database snapshot in the middle of the night, a very common DevOps task. You can integrate with CloudWatch events, so you can have an event fire every night at 1 a.m., trigger a Lambda function, and that Lambda function can take a snapshot of your database. Really cool way of automating some repetitive tasks. So that's it for compute in terms of infrastructure. Now I want to talk about how do we actually create and manage our infrastructure. In the past, as a DevOps engineer, you would have to go into the AWS console, click around, create things manually. If you needed to create, multiple copies of infrastructure, you'd have to duplicate all this. It can take a lot of time to do this type of stuff. Or you can use the AWS CLI, which is a little bit quicker, but not that great. Now, these days, people aren't doing it this way. They aren't creating their infrastructure manually. What they're doing is relying on infrastructure as code. So in other words, they want to create their infrastructure using coding or programming languages. And there's a couple different ways that you can accomplish this in AWS. Now, the first way is through a service called CloudFormation. This was AWS's first attempt to do infrastructure as code. Now, with CloudFormation, you define template files that are either in JSON or YAML format, and you specify all the different AWS resources you'd like to create as part of your CloudFormation stack. You upload that CloudFormation JSON or YAML file to CloudFormation, and it'll be responsible for going out and creating all these resources. This was a really effective way to create your infrastructure. Now, there's a much better way in modern times to create your infrastructure, and it's through a different solution on AWS called Cloud Development Kit. Now, Cloud Development Kit, or CDK for short, is different than CloudFormation in that it allows you to write actual code to create your infrastructure. So since we're using code, we're able to take advantage of a lot of different constructs such as for loops, while loops, primitives, all that kind of stuff. And this makes our life a whole lot easier. We can very easily define some very dynamic code that can be smart about what type of infrastructure it wants to create. So CDK is what everyone is, or not everyone, but a lot of people or most people are using these days. So if you're trying to decide between one or the other, you probably want to go with CDK. But spoiler alert, CDK uses CloudFormation behind the scenes, so you probably want to know how that works too, or at least a little bit of background information on it. Now, alternatively, a lot of companies that use cloud services from many different providers can use Terraform. Now, Terraform is built by HashiCorp and it's not native to AWS, but allows users to define code or templates that define how they want to create their infrastructure. So this works well in organizations that are using cloud computing resources across many different providers. Now, typically, folks will either use either CloudFormation plus CDK or Terraform. They typically don't mix and match. But of course, this is usually very dependent on the organization. But if you're not sure, I would either suggest Cloud Development Kit or Terraform to start. Okay, so those are some of the key concepts for infrastructure now. I want to move on to security. Now, security, of course, is important in the cloud. We're hosting all this infrastructure in the cloud. It's not on-premise anymore. It's up in the air. So we need to make sure that we secure our resources correctly and don't allow bad actors to access them. So how can we do this? Now, the first and easiest way that you should be familiar with is through IAM policies. We touched on this earlier when we were talking about essentials, but essentially you create policies, attach them to users or infrastructure, and that user or infrastructure will now have access to a particular resource or a particular service. So a very effective tool for managing who has access to what. Now, another great tool that's used at the networking level is VPC security groups. Security groups are entities that you can attach to a piece of infrastructure that will tell AWS that only a particular group of other infrastructure is allowed to interact with this piece of infrastructure. So for example, if I have a database that's hosted in my VPC, I can attach a security group to say this database is only callable from folks that are within another security group, and that other security group can be, a group of EC2 machines, it could be a Lambda function, it can be an ECS Docker container, or anything like that. So VPC security groups are really effective for locking down access at the networking level. Now, also in terms of security is CloudTrail. Now, CloudTrail is a tool that allows you to monitor and record account activity across your infrastructure. So it answers the question, who accessed something, what did they access, and when did they access it? This is great from the perspective of auditing and record keeping because it really allows you to hone in on who is accessing your resources. Or heaven forbid, if someone was, an abuser was interacting with your services that you didn't intend, you'd be able to track down how they did it, when they did it, and all the details in terms of their interactions. So a very effective tool. You need to enable this on your AWS account to make it work, but something that you should be aware of. There's a whole bunch of other AWS services that fall into different security categories. So things like prevention, awareness, auditing, different kind of sub buckets of security. But I think these are the main ones that you need to know about in order to be successful, or at least this is just a good starting point of services and concepts to be aware of. All right, so the next section is about monitoring. Now, monitoring is very important, especially as a DevOps engineer. You're going to need to be aware and need to know if your services are acting out of the ordinary or if your software applications are doing things that they shouldn't be doing. So how do we monitor these applications? Well, there's only one real service that AWS dedicates to monitoring, and that's called Amazon CloudWatch. And this is kind of a big service. There's a lot of moving parts and a lot of different components that do different things. But what I want to do here is just highlight some of the key things that you should be able to do, some of the key concepts that you should know about if you're a DevOps engineer using CloudWatch. Now, the first one is in terms of metrics. Now, what are metrics? Metrics are just pieces of information with regards to a particular service over a period of time. So for example, if we're looking at EC2 and we're hosting a software application, one of the critical metrics that we should monitor as a developer or a DevOps engineer would be something like CPU utilization. If our CPU utilization ever gets too high, then that could be a problem for our application. All of the different services in AWS have different metrics. And so as a DevOps engineer, you may need to do some digging or do some understanding of the different metrics that are relevant in terms of what you're trying to monitor. So in addition to knowing the metrics that you should be tracking, you should also know how to find metrics within CloudWatch. You should know how to graph those metrics over periods of time, know how to bucketize them, and know how to interpret the results of a metric being shown on a graph. The next one is in terms of alarms. If metrics tell us information about our applications, alarms notify us when things aren't going well. Now, what you can do with alarms is you can attach them to particular metrics, and they can fire after a period of time where something is happening that shouldn't be happening. So for example, back to that CPU utilization example, if we have a scenario where we have CPU utilization that is over 90% for 15 minutes, that could be an indicator that there's something wrong with my software application. Maybe I need to auto scale, I need to add additional hosts to my cluster to reduce the stress on that one machine, or maybe there's a bad actor that's running a script against my service or doing something malicious, who knows? But alarms allow you to be proactive and allow you to detect when things aren't going well. And alarms have actions that can be associated with them. So you can trigger an email, a text message, you can trigger a page so you can get notified. But alarms are just meant to keep you notified when something goes wrong in your applications. Now, also important to know is how to access and interpret logs. Logs give us some very critical information in terms of what our application is doing, things like exceptions, things like debug info. There's a lot of context that you can gather from logs to understand what your application was doing at a particular moment in time. So also very useful. Know how to find logs, know how to search through logs. CloudWatch Insights is a very useful tool for using SQL-style queries to look at your logs. I encourage you to check that out as well. So the last one in terms of monitoring is knowing how to create dashboards. Now, as a DevOps engineer, one of your roles is going to be to ensure that your applications are running correctly at all points in time. How do you know if everything is running well? Well, you create dashboards, and dashboards are just one-stop shops. And you can come to these dashboards, which are pretty trivial to create in AWS CloudWatch, and you can add all different types of metrics to your dashboard. You can add different alarms. You can add different logs that you can look at as part of your dashboards. But essentially, dashboards should tell you at a very quick glance, is my service running correctly? And if it's not, then you should have access to all of those key metrics also on your dashboard so that you're able to come to a conclusion in terms of root cause of any type of problem. So these are the key components of monitoring. I highly suggest as a DevOps engineer, you really understand each of these areas because they're going to be a critical component of your job function. Now, in terms of how to approach learning all this stuff, I know I threw a lot of it at you here. Honestly, I would probably start with the top row of different AWS concepts and services. So essentials, CI/CD, and infrastructure before moving on to monitoring and then probably security. Now, in terms of how you can get started, how you can learn, there's some great resources out there. Some great ones are a Cloud Guru DevOps certification. A Cloud Guru is a great resource, but it's kind of expensive. If you have the money or maybe your company can pay for it, it'd be great to take this certification course. Covers a lot, if not all of the topics I discussed here and more. So it's great to take a look at as an option. Another option is the official AWS DevOps training plan, which gives you, some real life examples to work through in addition to teaching you about all these different concepts. And it's of course coming through the official AWS avenue. So of course the quality is going to be top notch. And then if you're not interested in kind of doing this in a more structured way, there's a lot more other resources like YouTube. Like I have a lot of videos on all these different topics or most of these different topics. There's Udemy courses, Coursera, a lot of different things that you can piece together to learn at your own rate. So I hope you enjoyed this video. If there's anything that you think I missed in terms of what a DevOps engineer should know or what should be incorporated in their learning path, feel free to add it to the comments section below. And if you like this video, please don't forget to like and subscribe, and I'll see you next time.